anonymity to transactions called ZK snarks, the zero knowledge proofs. And so, because right now, yeah, if you make a transaction on, let's say, Bitcoin, you can trace exactly all the addresses where that came from, and a lot of addresses are labeled already now by private entities. Right? Because either they say or we can figure it out pretty easily. But with something like a zero knowledge proof, like ZK snarks, the technology, it would allow you to have another private key that would allow you to cryptographically sign a challenge of somebody asking whether or not something specific happened. So let's say so for example, if I wanted to pay someone $20 with a coin, with Bitcoin, I would just send it to them. But with ZK snarks, I could send it anonymously and then prove to them that they got it in a different way without them seeing the blockchain, that part of the blockchain. So there probably will be more anonymity coming with cryptocurrencies.
Or less if the
Bitcoin
government
doesn't
wants to
have
trace it. I mean, I want to know where my Bitcoins are going, right?
Well, some
Remember,
coins
cash
are-
has zero, or cash is fully anonymous.
Some
So anybody who
coins
talks about it
already have anonymity.
Oh yeah, like Monero does, right?
Zcash.
does.
You just can't see the transactions happening.
Right.
You can't actually see.
Everything's encrypted. Everything's kind of jumbled. It's all encrypted, and then the person who sent the transaction has the private key of the encrypted kind of transaction block. And so if someone were to ask them a question about that block, they could prove knowledge about it by signing it with a private key, but without actually having to reveal the block. Right?
Well, there's different types of anonymity that you might need, right? So maybe you care about just protecting the information in the transaction. So maybe we can see that party A talked to party B, but we don't know what happened in that transaction. Or maybe we don't care about what's in the transaction. We want to keep the parties anonymous. So there's kind of different levels of anonymous transactions you might need. And like Zcash, for example, will use ZK snarks, but you can decide how much or how little of that you want to make anonymous.
Right.
And there's trade-offs to each kind. But ZK snarks, if you're interested in anonymous transactions, read up about ZK snarks. There was a great talk done just 2 or 3 weeks ago down in Cancun at DevCon. You can look that up on the Ethereum Foundation's YouTube, but a lot of cool stuff going on in this area right now. And I don't know that the government can control that because it's open source software. But what you'll find is like with cash, right? I mean, if you just show up at a bank with $20,000 worth of cash, like they can't accept that if they don't know where it came from, right? So same way if you want to deposit your Bitcoin to a bank, like they're going to need to know where it came from. So even if you did all this stuff in the background to keep it anonymous, it still may be tainted somewhat. So like there's trade-offs all around.
Yeah. I guess, but if every coin was anonymous, it would make things.
I don't think that would be the case.
Yeah,
I think
probably not.
that banks
Yeah,
are
white
creating
coins, gray
their own
coins.
private chains, and to connect to the public world and the private world, there's going to have to be onboarding and offboarding. And if you want to move your public, blockchain stuff into permission chains of the banking world, you'll need a way to prove that it's yours.
But what if you're spending your coins at Best Buy? Are they gonna ask you where they came from?
I don't think Best Buy's going to be around.
Well, you know what I mean. You know what I mean.
No,
Yeah. Probably not, but you know what I mean. Okay. Anyways, and raised some interesting questions. So, this is another, I guess, what not to do probably. So this is a story from my brother actually. He said one of his friends bought a bunch of Ethereum, right? And he had it on his, he opened a software wallet, whether that was Parity or whatever, I'm not sure. And then he saved, he diligently saved his wallet file on his laptop. And then he was going to transfer that to a paper wallet, which we're going to talk about a little bit. But he just was kind of procrastinating, didn't want to do it, blah, blah, blah. So then at one point, and so a month passed or whatever, and then his MacBook had like a fatal error or something, right? And so he couldn't boot it up. So he had to send it in. He sent it in to like Geek Squad or whatever, like the MacBook Geek Squad. And Just imagine how he was feeling at that point. So then what actually happened was, I guess they fixed the issue and they didn't format the hard drive. But then on the way back in the mail people lost it. So it's gone. The MacBook is gone. Ethereum gone. And what's funny is the Ethereum was actually worth like orders of magnitude more than the laptop at this point, because like time had passed since he bought it. And then about a month later, the mail found it and sent it to him. He got it. But like, don't do that. So, yeah. That's it. So I guess now we're gonna backtrack and just kind of get into some of the low level. What is cryptocurrency? How does it work fundamentally? Before we get into the right ways of storing it, just because you can't it'll make more sense, I guess, right? So a private key is the number that you would store money on in these systems. It's just a random number between 0, probably don't pick 0 and 2 to the power of 256, because there's 256 bits in the number. And so we're talking in bits because this is all based on computers, right? So it's all going to be stored in the computer anyway. It's really hard to write down 256 zeros and ones. So there's been devised a system, actually this is an existing system, hexadecimal, where you take 4 bits and you, instead of writing it out as the 4 bits, you write it as a character from 0 to F, where F represents 15. And I guess most of you understand hexadecimal based on the hands raised earlier, so I don't want to get too much into that. But it's the same way that color codes work. So if you don't get it, you can just read about hexadecimal. So you'll see those addresses up there. Those are going to be in hexadecimal. So you don't see any letters after F. And they're really just binary, but they look like hexadecimal right now. They're base 16 instead of base 2. So we want to open a bank account on Ethereum. You need to just pick a number, but then you also need to derive the address from the number, and there's a one-way mathematical algorithm that allows you to get from that top number to the bottom number. The bottom number is not a random number. It's actually dependent on the private key above it. So the lower number would be the public address. Those are shortened versions, but you get the idea. So if you have the private key up at top, you can run through the function and get the public address at the bottom. But there's no way to possibly find the private key from the public address. So you can go down, but you cannot go up unless you brute force, which is not possible with today's computers.
Excuse me.
Yeah.
You said it is 16 digits hexadecimal.
Mm-hmm.
256 bit is 64 hexadecimal.
Oh yeah. So imagine the top number there is 64.
So is
hexadecimal
it 16
digits
or is
long.
it 64?
64 hexadecimal
Okay.
characters.
Okay.
Yeah.
Well, I would just say
Is the private
it depends too what cryptocurrency is.
yeah,
Right? So
this is
Bitcoin
just
is going to be
Bitcoin.
different than Ethereum.
That's true.
Different
That's
than Monero.
I'm using Bitcoin right now as an example. Most cryptocurrencies are similar, but they have their nuances and differences. I guess if you understand Bitcoin, you'll pretty much understand everything else. Well, yeah, you'll have a baseline foundation,
I'm biased.
and then you have to probably read more. Yeah, that's true. There's, a lot of technologies are just being built every month. It's crazy. It's awesome. So you could potentially do this calculation from the private key from a public to a public address on a calculator or like on paper. It would involve elliptic curve math, and it would be really difficult to do. Yes, you'd have to be like a skilled mathematician. There are guides though, so you can go ahead and do that. And that's actually probably one of the most secure ways to do it. I wouldn't recommend it. So, or you could also use software on a computer that opens you up to some vulnerabilities if you're not careful, right? You can use a web page, which opens you up with even more vulnerabilities, but a lot of people still do it. Or you can use a hardware wallet, which we're going to have a demo. We're going to talk about that a little bit more. So yeah, a lot of people love using the hardware wallets. The only disadvantage of a hardware wallet is it costs a little bit of money, but other than that, it's all advantages.
Safer than sorry.
Yeah, it's all advantages, right? So we can also do, to make it even easier to remember than the hexadecimal up there, and even shorter to write down, there you can use a function to convert that to a seed phrase, like we already talked about this briefly, right? So 12 words, you can convert that private key to the 12-word seed phrase, or they can go for the 12-word seed phrase easily to the private key. So you can just write down those 12 or 16 or however many words, and then it would get you back to that private key. And like the dictionary and the functions and methodology for that system is called BIP32. Is one of the main methods of doing that, generating a seed phrase, and it's kind of just industry standard right now. Yeah. Oh yeah, get it quick. Oops, I accidentally put my actual private key.
No.
That's an example of a public address. So I think it's Ethereum, yeah. And so you can also represent it as a QR code because it's just data like that. So you'll see QR codes. So you can actually send money to people through images, video, signs, all that. That's kind of one of the other cool advantages that I didn't even mention. Now you can send money to people through like an image, which is kind of weird. Super weird. Super cool. So yeah, like I was talking about briefly, cryptographic math.
Etherpunks. Oh, sorry.
Oh yeah. Oh yeah. So cryptographic math, Etherpunks is a website that I built. I don't know. It's like it's just a visualizer of Ethereum transactions as they come, as they go through the network. Anyways, that's kind of silly. So elliptic curve digital signature algorithms are used for the basis of the math behind all of this and signing transactions on the network. So typically, your coins or Bitcoin or what have you is sent to a public address. You send coins to the public address, and then you spend it using the private key. But what's really cool is that you never divulge the private key to anybody else when you spend the coins. You're using this cryptographic math in just the same way that a browser uses the encryption and cryptographic math. So that what's happening is, you say you want to send, 1 Bitcoin to that public address, from your public address, and so your public address is A, and that public address is B. So then the network says, okay, hey, prove to me that you own address A, and then use this use this challenge word or challenge number to do it. So then you take the challenge, key or whatever, challenge number, and then you run it through a function with using elliptic curve digital signature functions with your private key, and kind of scramble it up, and it bakes a little cake, and you send that packet, that cake, back to the network. So you're not actually sending them the private key, you're sending them like the private key encrypted with their challenge word, basically. So then they get that packet, and they can mathematically, in a mathematically sound way, know 100% that you must know the private key because you sent them that packet, because they can run math on the packet backwards from their challenge, and it would actually spit out your public address. So that's how you're proving to the network that you own the private key without actually giving them the private key. Does that make sense? Yeah, that's the secret sauce. That's like the really, really, really secret sauce of this whole system. Without that, this wouldn't exist. But we actually already had this, and this is exactly the same thing that modern encryption does, but super cool. So, and I say Alice can prove to Bob that she knows her private key because in all the examples on YouTube of this, and basically in computer science, they always use Alice and Bob. It's like, so yeah, watch some YouTube videos that explain it. You'll learn something, I'm sure. You can just kind of research encryption, how encryption works, or how elliptic curve digital signature encryption works. Actually, if you look at YouTube videos of how elliptic curve digital signature algorithms work, prepare to have your mind blown. I could not even follow it. Some guys drawing line like a U-shaped parabola on a graph, and he's drawing lines over here, and don't even know. It's
So
crazy.
if you search for
And then-
public key cryptography,
You like
you'll
you,
find-
the challenge word is like a number, and then you have to like go. You have to like run it in, pick a point, go over here with geometry, find another point, and then come back over and do that X times, which is the number, which is might be like millions of times. Somehow the
I
computer
had
does
flashbacks,
that like really
flashbacks to
quickly.
engineering school.
Yeah, for sure. It's fun. It's fun stuff. Anyway, so but moving on from the technology, so does everyone kind of has a fundamental grasp of what at least we've said so far? That's really, in my mind, most of the meat and potatoes of the technology behind like Bitcoin. Would you agree? What else? What else?
I
am
mean, you
missing?
gotta talk about blockchains.
Okay. Oh yeah, for sure. Okay. So great point. Great point. So so we all had Napster. I guess I like to start like this. I guess we had Napster where you could download media from each other in like a decentralized way, but it was actually centralized. It was a centralized way, and then that was cool because now you could like file share. Then some guy came out with uTorrent or BitTorrent, I guess. Yeah, BitTorrent is the real term. BitTorrent is like because Napster was shut down, right? The guy was thrown in jail or sued or whatever. It was really bad. But the next guy was smarter. He said, "I'm going to make something that's decentralized so that it can't be shut down." And I think BitTorrent was one of the the first really big successful softwares that was decentralized that is resistant to attack. Because there's no brain, there's no like main piece of it. You can shut down like a part of it, but then the other parts will pop up, kind of like a virus or something. It's impossible to completely annihilate, and it'll actually evolve, I guess. Software updates or whatever. But so with BitTorrent now you can share files with each other, and there's no central hub to destroy. That same kind of methodology was used in the creation of Bitcoin, and maybe that's why the word bit is still used. I don't know, but basically, when you're running, instead of running like a BitTorrent client where you're kind of seeding and leeching files to one another, in this case you're running a wallet and mining client combined, which is like Bitcoin Core 1.0, which is also known as a node. And what this one piece of software does, it's actually like on GitHub, Bitcoin/Bitcoin or Bitcoin/Bitcoin Core or whatever. There's many other forks now, but what it's doing is you're storing the blockchain. If you're running a full node, you're storing the entire blockchain, which is the entire record of all Bitcoin transactions since the beginning, on your hard drive. And you're also listening for new transactions that are coming through from the network, which are basically requests from other Bitcoin core wallets or any other software that's using the same protocol, talk down the same protocol. And you're working with the other miners to build the next block of the ledger, and then you're all racing with proof of work. In Bitcoin's case, it's not always the case, right? But you're all racing to find a number so that when you attach it to all the block's data and then run a cryptographic function on that whole thing,